Hello and welcome back to AP Pre-Calculus. Today's lesson is 2.4, Exponential Function Manipulation. Let's start with a little algebra review of our exponent rules. So we'll start with the first one, the product rule. When you multiply like bases, and remember, a base just means it has an exponent, and everything has an exponent. If you can't see it, it's a 1. Okay, so everything is a base. If you're multiplying two bases that have the same base, then you add their exponents, right? We all know that x to the 5th times x to the 3rd is x to the 8th. But in this class, they're going to want us to rewrite things. Sometimes they're going to give us this piece, and they're going to want to rewrite it like this. So we started with 2 to the x plus 3. We could rewrite that as 2 to the x times 2 to the 3rd, okay? The power property. When you have a base on the inside of parentheses and an exponent on the outside, as long as we don't see any plus signs or minus signs in this parenthesis, then we can multiply the exponents, right? So we know that x to the 5th raised to the 3rd is really x to the 15th. If you want to think about it like this, to the 3rd means 3 of these guys. So it'd be x to the 5th times x to the 5th times x to the 5th. And then we're back to this property. But it's a shortcut to get us there, okay? What if I started you out with 2 to the 3x? Well, we could go backwards and put 2 to the x on the inside with a 3 on the outside. And we could actually write it one more way. We could put the 3 on the inside and the x on the outside. All 3 of these are equal representations of each other, okay? So sometimes we're going to have to write things in different forms, equivalent forms. And lastly, our negative exponent rule. So sometimes your question will have to be answered without negative exponents. It's not that negative exponents are bad. It's just sometimes we want things to have positive exponents, right? So I need you to think of all things as fractions also, right? When we say, hey, we can't have negative exponents, we have to move that base and exponent to the other side of the fraction. It doesn't mean we always move it down, because sometimes I might have 3 over x to the negative 5th, and I go, well, I got to rewrite that as a positive exponent. Well, x to the negative 5th is in the denominator, so if I need to make it positive, I can just put it up in the numerator and make it 3x to the 5th. Now the 5 doesn't go with the 3 because the 3 already had a 1 there, so we don't need to put another one there. So think of negative exponents. If you have to rewrite it with a positive exponent, you're changing where it is in the fraction. If it's in the numerator to start, it goes in the denominator and vice versa. Okay, so let's go ahead and down here and look at example 1. And they want us to determine the horizontal transformations of each of these. Remember, horizontal transformations are the things that are inside the parentheses with the x. And you might be looking at me going, well, there are no parentheses. Well, that's where math gets you, because we have a lot of hidden parentheses out there. And if you've ever taken your calculator and tried to raise something to a power, it actually starts a parenthesis for you if you have the TI-84. So there are actually parentheses up here in the exponents that you don't see, okay? So that means we have horizontal transformations if you have numbers in there with the x. So let's look at the first one. 4 to the x plus 2. Well, remember, we're doing the opposite. I see plus 2. That means this is going to shift left 2. And unfortunately, we can't write it as left 2. That was algebra 2. We need to say it is a horizontal translation of negative 2. I wish we could say left 2, but the AP board, they're really wanting us to use better language, okay? Let's look at B. I have a number in there. It's not a plus sign or a minus sign, so it's not going to be like a translation. It's not going to go left and right, but it is going to be a dilation, right? So we have to do the opposite. It looks like 3 times x, so we have a horizontal dilation of 1/3, right? By the way, is there another way to write these two things? Let's go back to A. If I wanted to rewrite this in a different way, I could write 4 to the x times 4 squared. That's the same thing, right? If I wanted to write this one, I could write 2 to the third raised to the x. And actually, there's more ways to write that. I could do 4 squared. I could write this 16 times 4 to the x. I could write this 8 to the x. Now, I couldn't go any further than that. I can't go over here to this 16 and the 4 and multiply those together and get 64. Remember, the rule. If you're going to multiply bases, you can't see exponents, or they need to be the same thing, okay? So if that was a 16 and a 16, then yes, I could do something different, but they're not. So we would leave this guy alone, okay? Let's keep going on. Let's look at C. Now, this guy, it looks like I got a horizontal dilation again. Don't see any plus signs or minus signs, so it's a dilation for sure. I'm dividing by 2. What's the opposite of that? I'm going to times 2. How could I rewrite this guy? Well, to be honest, this could be written like this, 1/2 x, which means I could write this as 9 to the 1/2 raised to the x. I could go even further because 1/2 means square root. I could rewrite this as 3 to the x. So look at all those different ways to write the exact same thing. That's one of the things they want us to be able to do in AP Pre-Calculus, okay? All right, let's keep going. The last one, put our parentheses around the x minus 1. That looks like a horizontal translation of positive 1. Okay, you probably could just put 1. You don't have to put the positive there. And again, we could write that in a couple different ways. All right, let's move on. All right, if you read through this page, you'll see it saying some of the things that I had already said in the last slide. We have that same 4 to the x plus 2 when we rewrote it. And remember, I said that we could simplify this part right here because I could do 4 to the second. I don't know what 4 to the x is, so I got to leave it 4 to the x. But 4 to the second I know is 16. And please, please, please do not be that person that multiplies those two together and gives me 64. It hurts my heart, okay? So what do we have here? There is no longer a horizontal translation. We've changed it up a little bit. But because we changed our starting position, we would actually graph the same thing because now I have a vertical dilation of 16 instead of a horizontal dilation, horizontal translation. It turned into, I know it seems weird, but if you went to Desmos and put this in one line and then put this in a second line, they're going to be right on top of each other. All right, so there's different ways to write the same function. So here's an important idea. For every horizontal translation of the exponential function, there is an equivalent vertical dilation that we could write in a different way, okay? So let's see if we can figure this out. So right now, it looks like there is a horizontal translation of -3. But let's rewrite it in the different form. So since they're adding, I could rewrite this as 2 to the x times 2 to the third, same thing. Clean that up a little bit. That's really an 8 times 2 to the x. So these two guys are the same thing. The original showed a horizontal translation of -3. The second one, when I redid it, it's showing a vertical dilation of 8. Try the next one. Let's rewrite it. 3 to the x times 3 to the -2. Okay, what is that? Well, that's 3 to the -2 is really 1/9 times 3 to the x. Last but not least, boy, C looks a little weird. So let's rewrite it. So we got 4 times 3 to the x times 3 squared. All right, let's clean that up a little bit. We got 4 times 3 to the x times 9. Now remember, I said you cannot multiply bases if you see an exponent. Well, I don't see an exponent with 4, and I don't see an exponent with 9, so I could actually multiply those together and get 36 times 3 to the x. All right. All right, here are some very common multiple choice type questions they like to give us here. We're looking for an equivalent form of a function that they gave us, right? So what I have over here, I would take my 9 and I would do 9 squared to the x. Like, what is another way that that could be written? Well, I know what 9 squared is. That's 81 to the x. And there we go, right? So don't look at your answers right away. Do a little work on the function that they gave you and see if you could come up with a different way to write it. So let's do this one over here. Y equals 9. Well, man, what am I going to do with this one? Well, I can't multiply the 9 and the 4. So what could I do? Well, I don't really can think of anything to do with the function, so let's go ahead and look at the answers. So some of them turn the 9 into a 3, and I don't really see what they did with the other 3 that would make the 9, so I'm not choosing A or B, okay? The 9 is stuck. The other ones turn the 4 into a 16, right? So if I looked at this 16, how could I rewrite it? Well, remember that I could rewrite this as 1/2 x, which means I could get 16 to the 1/2 x. This one down here would be 16 squared x. Well, 16 squared is 256. That's not what I have over here. But 16 to the 1/2 power, remember 1/2 is square root. And square root of 16 is 4. So I'm going with C. And that's today's lesson.